Good morning or good afternoon, depending on where you are at. My name is Atarot Azizin Amini. I'm Director of the Innovative Bridge Technologies / Accelerated Bridge Construction, University Transportation Center, and very warm welcome to more than 500 people who have registered to listen to us live. Today, we are delighted to bring to you a very interesting webinar, our monthly webinars, December 2024 webinar. And if you notice, actually, this month we started our webinar a little bit earlier than usual. And the reason for that is because next week, as you know, our conference is going to be starting. And that's why we try to avoid the conflict between the webinar and the conference. So the title of the monthly webinar is ODOT combines multiple ABC method for maximum value at I-5. So we are delighted to have with us Joel Tobbs with the Portland Bridge practice, and also Robert DeVossis with the manager, Oregon Department of Transportation. During the registration process, we have received a number of the questions, and we're going to try to get to them as time permitted. But if additional questions you have, please post it on the dashboard, and we will try to get to them as time permits. This time, I'm going to turn it to Kathy Kroll, who is going to be sharing with you some additional information related to the bridge engineering. Kathy?
Thank you, Torad, and thank you all for joining us today. I'm Kathy Kroll. I'm the Co-Director of Technology Transfer for the IBT ABC UTC. Before we start the featured presentation, I'd like to share some upcoming events with you, both from the IBT ABC UTC and our industry partners. First is the PCI, Precast Prestressed Concrete Institute's 2025 convention at the Precast Show. This will be February 3rd to the 7th in Indianapolis, Indiana. Registration is currently open. You can find registration and additional information at the link on the screen. Next is the AISC NSBA, the American Institute of Steel Construction National Steel Bridge Alliance, the Steel Conference, which includes the World Bridge Symposium. This is April 2nd through the 4th in Louisville, Kentucky. Registration opens January 8th, and additional information can be found on the screen. Next is the American Composite Manufacturing Association. The Design Using Pultrusion Technology Conference is May 6th through the 8th in Chicago, Illinois. Additional information can be found at the link. The next announcement is for our next monthly webinar, which will be in, it says January 2024. We're not going to turn back the clock. It actually is January 16th of 2025. We will be featuring seismic connections of precast columns to foundations utilizing UHPC. We'll be joined by Dr. Marcia Net from the Polytechnic in Montreal. Please join us to learn more about UHPC. And that brings us to today's webinar. Before I introduce our speakers, I'd like to make just a few announcements. I'd like to thank you all for joining us for today's 165th webinar in the monthly webinar series. As many of you may know, these webinars are recorded and posted on the IBT ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation is provided in the Go-To dashboard on the right side of your screen. You can download these PDFs during the training session, and they will also be posted to the archives. Lastly, this presentation will be followed by approximately 15 minutes of question and answer. Please enter any questions you have in the question box in the Go-To dashboard. With that, we will begin our featured presentation. We welcome Joel Tubbs, who is the Portland Bridge Practice Lead at David Evans and Associates, and Robert DeVassi, who is an agency project manager at Oregon Department of Transportation. We thank Robert and Joel for sharing your time and expertise with us today.
Thank you.
Thank you.
Yeah.
Can you see the presentation?
We
Yes.
see the presentation and we hear both of you. Great.
Great.
All right. Excellent. Well, let's get going. Good morning, everyone, or good afternoon. We're excited to be here. Next slide. All right, so we are here to go through the I-5 over 26th Avenue Bridge project and show off some great benefits. Some of these include reduced construction duration by 6 months, major impacts to the traveling public from 2 years to a single full weekend closure, a construction cost of $5.5 million reduction, safer work zone for the contractor and traveling public by building the structure underneath the existing bridge, then removing the existing during the weekend full closure. Reduced waste and emissions by not constructing a temporary detour structure and reusing demolished bridge waste as roadway fill. A project that not only saved taxpayers money, but also added value to the community. We also recently won the Oregon ITE Project of the Year award. Next slide, or next image. And we also will be on the cover of our 2025 Highway Design Manual. Next slide. So just a quick snapshot of the facility. You can see that it's pretty heavy on truck vehicles, heavy vehicles. Our goal was to replace the bridge with minimum impacts to I-5. Next slide.
So thanks, Robert. I'll take over from here and speak a little bit about the bridge. The existing bridge was a 3-span concrete bridge, a deck girder bridge built in 1959 and was widened and overlaid in 1985 because the details of the bridge were not couldn't keep up with the loads that were our transportation facilities were exposed to over time. There was some cracking in the deck and some delamination that happened that justified the overlay, and then soon after the overlay was placed, it continued to crack and delaminate. The facility, I-5, has very substandard shoulders and is highly congested in this area with long hours of delay because of how congested it is. And the existing bridge is supported on timber piles. There was a project before our project to consider retrofitting this bridge, doing a rehabilitation for seismic, and they decided that it would cost too much to do the rehabilitation and replacement was justified. So the scope of our project, really the objectives for our project, were to replace the structure with a new structure that could meet today's seismic standards and static design standards for that matter, using traditional construction methods. That was the original scope of the project. We were to maintain all 6 lanes of traffic, 3 lanes of traffic each way, I'll say at all times. We were going to widen the shoulders from 10 feet to 12 feet so that when maintenance crews are out there, they don't have to close a lane down. And there was an adjacent City of Portland project where they were improving the local street underneath. Excuse me, sorry. Improving the local street underneath. And so we coordinated with the city to take over part of that project or construct part of that project for them as part of this project and tie into the rest of their project. Design and construction was to be completed within 36 months. That was primarily because we had, ODOT had many large projects in the metro area that were going to be constructed starting in 2025. So we had to get in and do our project in a somewhat accelerated time in order to have our construction complete in 2024. And as part of this project, we were, ODOT wanted to do a value engineering study to make sure that to be in the best stewards of the public money as they could be for, for this facility. So we went through and started working on our 30% design. The existing bridge, like I said, was a 3-span reinforced concrete deck girder structure. That's shown in the red on this view. On the black in this slide is the replacement, the 30% design. It was a 100-foot long welded steel plate girder with the supports located between the existing abutments and the interior piers. And it and the concept would we would demolish the existing 3-span bridge and construct the single-span structure in using stage construction methods, completed in 5 stages. And there would be, of course, an island work zone where the contractor would have to be working in between traffic. There would have to be a construction, a detour bridge that would be constructed in order to shift traffic off the existing southbound direction, and they would maintain traffic in the northbound direction in stage 3. And that's the island work zone. And then there would be, traditional kind of shifting of traffic and stage construction and demolition from that point on. At the 30% design, our construction cost was estimated to be at just over $19 million. So some of the risks around the more traditional construction approach that we had at 30% design was right-of-way was very tight. So we didn't have a lot of room to put in the detour bridge. It was going to be substandard alignments or pushing the limits anyway on the alignments for the detour structure, and we'd be right up against the right-of-way. There is a water quality facility that was located adjacent to the structure. And that facility treats the stormwater for quite a long range along I-5, as well as the local streets in this area, because the bridge is located kind of in the dip of this region. It's kind of the low spot in a region here, and so a lot of the stormwater comes to this water quality facility, and impacting that facility, which would have been impacted by our detour bridge, would require upgrading that facility to current standards, which would have cost millions of dollars just in itself. And then, of course, as I mentioned before, there was the PBOT project on 26 Way that we had to accommodate as well, and that factored into some of our decisions there. So at that time, we got to the 30% design, and that was the scheduled time to go through a value engineering process. And if you've never, this group probably has been involved in these processes before, but just to give a little bit of information, it can be an extremely important process for projects to make sure that the use of the public funds are going as far as they can be. It's the way that, when it's done right, I'll say, is it's a very systematic and structured approach to figure out to get the most value out of a project, the products, the processes, and the services. And one of the most important aspects of it is really to put on your creative hat and think outside the box and see if there's some innovations that you can do, or some ways to really capitalize on that value. And of course, the value is increased by increasing your performance of the requirements that you're trying to satisfy. But then also, that's largely, value is also largely by reducing cost, time, and risk. So there were, I think, 10 alternatives that were proposed by the value engineering team. It was a mixed team of consultant staff and agency staff, and the design team was a part of the process, of course, in helping the VE team lay out the requirements, or the goals, I guess, for the VE study, and then also responding to the VE alternatives that were presented. So this first one was presented as the one that would have the most value. It was essentially to build a 3-sided box, like a concrete arch culvert, you might say, in the center span of the existing bridge, and to fill around that culvert with low density cellular concrete up to the bottom of the deck of the existing bridge. And the benefit to that was the existing bridge would just be left in place. It would be supported by the concrete, by the low density cellular concrete, and effectively by the structure, the new concrete arch structure. And then a lot of the issues with the deck were believed to be taken care of because it's now supported on concrete. I disagreed with that a little bit with when it was presented and in our response to it. Just the difficulties in making sure that concrete, that LDCC would actually solve the problems with the deck. I really struggled with that. So there were some constructability issues that I was concerned with that. I felt like the condition of the deck was bad enough. It would just remain bad enough so the asphalt overlay that would be put on top of the deck would just still be become cracked and have a reduced service life because of that. Also, the timber piles, all of the weight of the bridge is still supported on timber piles, of which we'd have no idea of the condition of the piles, and they provide no seismic stability. So the next idea that they came up with is the one that that we talked about internally and decided that this would be still a great value for the project. And it's very similar to the, I'll call it Alt B, very similar to Alt A was the first one, in that it's still, building a three-sided box in the center span, placing LDCC around that structure, but only taking the LDCC up to about the bottom of the existing superstructure. And then coming in and demolishing, after that is all constructed, demolishing the existing superstructure and replacing it with pavement, with fill and ag base and pavement, so that you're not actually driving on the deck of the deck of the existing bridge that's in poor condition. So it mitigated the deck condition concerns, mitigated the concerns about the timber piles because the load of the structure is no longer supported on the timber piles. And but both of these options, I should mention, have pretty restrictive clearances with the shape of the arch. A lot of these arch products, they're limiting in the clearance. So both alternative A and alternative B required lowering of the existing road, which had some complications associated with it, and also was required the traffic to be just located right in the center of the arch because of the shape, the rounded shape at the top of it. We did talk about some other structure types that didn't have that rounded shape, and afforded us the ability to kind of open things up a little bit more underneath there. I want to note that the VE alternative assumed that the demolition of the existing bridge would happen in stages, and that was troubling to the traffic team. And so we came up with our final concept was similar to alternative B, where we ended up demolishing the existing superstructure, but we instead of using the arch culvert section, we used a pre-stressed, an ODOT standard pre-stressed precast concrete slab, and that opened up that clearance to 26th Avenue a little bit. Had a more consistent clearance, I should say, across the whole width of the required horizontal opening, and allowed us some flexibility from a traffic standpoint if we wanted to stage traffic within that opening somewhat. There was no lowering of 26 that we ended up not lowering 26 because of all the complications that were associated with that. We felt like we could just live with, I guess you might say, the clearances that we end up with. And since no trucks really have to go under here, we settled on a number that everybody was happy with. There was something that wasn't addressed in the VE study was settlement mitigation, because we were using low density cellular concrete, but even with the weight of the lightweight nature of that fill, there still was some additional settlement concern because of the softness of the soils here. And we have the existing bridge supported on piles that we didn't want to add down drag loads onto. So we had to employ some settlement mitigation that I'll talk about a little bit later on. And because of the concerns about staging the demolition of the existing bridge, the ODOT traffic team required a full width, or required a weekend closure in order to do the demolition, and preferably a 1 weekend closure to do the full width of the freeway. And so we worked through how to accomplish that. So from concept to contract plans, here's just a shot of our contract plans, very similar to the concept. You can see the structure there. We accomplished, getting the wider shoulders like we wanted to. We're maintaining 6 lanes of traffic. We maintain the median width as well. We have, you can see in the elevation view down there, our over excavation for the settlement mitigation that we'll talk about here in a minute. Here's a cross section. The lower section, the bottom section here is before the weekend closure. Basically is these precast 4-foot wide precast pre-stressed concrete slabs that are, again, ODOT standard sections, which was important to us, instead of using a proprietary system like the arch culvert. On top of the slabs, you have LDCC to kind of fill in the gap between the top of the slabs and the existing girders, and that was primarily to provide a buffer to the slabs, so that when they're doing the demolition, they're not doing demolition all the way down to the top of the slabs. The upper typical section there includes, it's the final condition with some edge beams along the side to retain the fill that's on top of the slabs. You've got some stone, we called for stone embankment on top of the LDCC, ag base on top of that, and then asphalt pavement on top of that. So a few things about maintenance of traffic for this structure, for this project. We were allowed to close down 26th Avenue, the local road underneath, for most of the construction of the bridge, actually for all the construction of the bridge, really. And because there was such a short local detour, I don't have a map of that detour, but it was reasonably short. Cars can get around easily, and the community can get to where they need to go by car pretty easily. The 6 lanes, 3 lanes each way of I-5 were maintained, except for that weekend closure. There were also some nighttime closures after the weekend closure to do some final lift paving that we'll talk about a little bit later as well. But from a pedestrian standpoint, the vehicular detour was too long, reasonably, for pedestrians. And so we elected to, or this option really afforded us the ability to maintain pedestrians through the construction zone, through the end spans of the construction zone, or when we're doing the fill in the end spans, through the center of through the mid span or the center span of the existing bridge, while they're doing the fill in the end spans. I can't tell you how many people I heard from. There were several people that I heard from, both the people that I work with and members of the community, that were really pleased with our ability to maintain pedestrians through this area, because there's a local taco truck that is parked nearby that is a really popular destination for the community. So I thought that was kind of funny. Also, just side note, my parents love to go to different project sites with me. This was one of their favorites, and I would take them here, and we had the ability to walk basically all through on the pedestrian route here and check out the construction kind of as it was going on, and they just love that. So the highlights of this concept and this project were: you reduce impacts to I-5 traffic. Instead of having 5 stages of traffic impacts on I-5, it really reduces it down to about a weekend plus some nighttime closures. The bridge, this is one of my favorite stats about this project. For the bridge construction as well as the demolition, there was no I-5 traffic in the work zone. All of the work was either happening under I-5 for the construction, or the traffic was diverted around or detoured around other areas so that during the demolition, it was just a full width closure with no I-5 traffic. The project reduced construction costs, as Robert mentioned, and reduced the construction duration, and the pedestrians were easily accommodated. The bad, of course, you have to fully close I-5, and that comes with there's, I'll say, never a good time to do that, but with a lot of communication, I think it went pretty well. You've also got to figure out how to build a bridge under live traffic, and then how to demo the existing bridge on top of the structure, the elements that you just that you just constructed. So those were some of the challenges. So in the presentation here, I'm going to talk a lot about the accelerated bridge construction and other specialized techniques that we employed in order to accomplish this project. And the first one is a contractor constructability review. One thing I want to mention, especially for this crowd, I'm sure there's a lot of people here that have a lot of experience with any one of these elements. And it's not that any one of these are all that unique per se, but this project combined a lot of different techniques, and I think that's kind of what makes it special, at least for us here in Oregon. The constructability, the contractor constructability review, I'll talk about that more in a few minutes, but that was a very important part to give us confidence in what we're doing. We used micropile foundations due to the overhead limitations. We have precast concrete elements with the slabs. We laterally translated those beams underneath the existing bridge because we didn't have access vertically. We had to come up with a way to connect the slabs to the abutments after sliding them in with overhead restrictions. So that was a specialized detail we came up with. We used low density cellular concrete for the fill, but not only just for the fill behind the abutments, but also for the reinforced fill of a mechanically stabilized, typically called mechanically stabilized earth wall. But this is mechanically stabilized low density cellular concrete filled wall. For settlement mitigation, we used a near net zero approach where we over excavated to achieve basically a near net zero difference in pressure at the excavated surface of the ground. This was a concept from the contractor that came out of the constructability review session, but we reused the concrete debris from the demolition as fill underneath the ag base. And then we had the full width weekend closure for the project. So the constructability, I'm not going to spend a whole lot of time on all these slides. We've got a lot of slides to get through, so I'm going to touch on some high points here. But the constructability review session with the contractors were one-on-one sessions with 7 different contractors. Each session, like I said, is one-on-one. They can say what they want to, but everybody knew going into it that all of the findings or all the discussion was going to be published with all of the other contractors that attended the sessions. And so some of the items the design team was wondering about was the bridge demolition, how best to do that, and can we get that done in a weekend? The micropile installation, wanted to get some specific information about recommendations for that. The bridge construction, of course, how to accomplish getting the beams where they need to go, some of the specific details about how to connect the beams to the abutment and all that. The pavement construction, again, can you get that done? What are some things that we can do to make sure that can happen within that weekend closure? The retaining wall construction, at the time we did the constructability review, we were assuming the soldier pile walls actually to retain the low density cellular concrete, and that was because these LDCC filled MSE walls were not something that it's not something that's commonly done in Oregon. It was only done one other time that I'm aware of for ODOT, and on a much smaller scale. And so we had to go through a process to get that figured out. Some of the findings or opportunities that came out of that review were to allow the bridge debris to be used as a sub-base underneath the ag base. And so we decided to go ahead and allow that. One of the suggestions from the contractors was to provide a staging the stockpile area near the site, and also allow off-road haul trucks that could handle more load on the between that site, on the freeway between that site and the project site, and also to switch from the soldier pile wall to the MSE wall. We had mentioned our idea of using an MSE wall with the LDCC, but that we didn't think that our schedule accommodated the approval process to get that through, and they said it's a much better idea to try and just get through that process and use an MSE wall instead of a soldier pile wall. And then they also mentioned the concern about timber piling, this kind of known unknowns, you might say, from a risk standpoint of, we know that there's timber piles under the footings, but there's also possibly false work timber piles underneath that we'd have to deal with. So I'm trying to figure out if there's a concern about that. So getting into a little bit more detail about each one of these things, I mentioned the very soft soil, so deep foundations were required. We couldn't use shallow foundations. We had no vertical access to do traditional driven piles. And we had to do all this work with the existing bridge under live traffic. One point I wanted to make on this one was that we tried to locate the existing footings, but we had limited scope in order to do that. We didn't do a thorough enough job. So we ran into some issues during the design where not every footing was exactly where we thought it was, and we had planned on building our footings effectively right up against the existing footing. So that created some issues during construction that we had to deal with. The micropiles were designed for 330 kips of compression, 50 kips of shear, 250 kip feet of nominal moment capacity. And so that's just a little about the foundations. Here's a shot of during construction. There's a lot of photos coming up, so I'm gonna probably speed through those quite a bit, but such a messy operation. This was my first micropile project, and I was impressed with how messy it was. This is a shot of after the abutment walls were constructed. This is the end from which the slabs would be slid underneath the existing bridge. So you can see some things are unfinished. There's to accommodate the translation of those beams. One of the interesting things that the feedback I got from the contractor was, and you can see it in this picture, is they loved this job because it was all underneath the existing bridge. So in the heat of the summer, they had a nice shady area to work in. And in the downpour of the rain, similar situation. So the next thing is accelerated bridge construction. Again, there's no vertical access for setting the slabs, and no vertical access for connecting the slabs to the beams, and there was limited right of way. So we came up in design with a scheme that then the contractor actually followed pretty closely. Which was with the limited width that we had to work in from a right-of-way perspective and for other impacts from the water quality facility. We build some temporary false work to the, I'll say route direction west side of the freeway. And we would set 10 slabs, that's all with the room that we had there. 10 of the 28 slabs would be on the set first. We would connect all those together following traditional standard ODOT details. And put a waterproofing membrane using a multi-layer polymer concrete overlay, which added a little bit more protection also for demolition. And then we would slide those, in step 2, we would slide those 10 under the existing bridge, set 10 more, go through the whole process again, connecting it to the first 10, and then slide all 20 of those beams underneath the existing bridge, set the remaining 8 beams and connect them with the previous ones, and then slide all 28 in step 4 to their final position, and then remove all the false work after the beams were set on the bearing pads. So some details about that. This is just a shot during construction of the temporary false work and the first 10 beams that are placed out there. We had assumed that they would push the slabs. There's a little bit of an uphill grade on 26, and the slabs followed that grade. The contractor decided to pull the slabs instead of push. One key element to whenever you're moving these slabs, it's all a hydraulic system that has a manifold so that things are moving the same together as you're doing that. But that's super critical that everything's happening the same rate at the same time so that things don't get askew. This is a shot showing during that process, the way that we connected the slabs to the top of the cap, we had in design assumed actually that they would not pour the cap until after the slabs were in place and sitting on the temporary false work, and then pour up, and then set the bearing pads and lower the slabs down onto the bearing pads. The contractor elected to have a trough, more or less, constructed in the cap that would accommodate dropping of a pin. There's a hole in the end of the slab, and the dowel that connects the slab to the abutment is more or less the same height as the slabs are deep, or the same length as the slabs are deep. And so when the slabs were in final position, they just kind of pulled the string and allowed the pin to drop into the trough, and then grouted the trough around the pins. They also elected to adhere the bearing pads to the bottom of the slabs, and then kind of seal the area off around the bearing pads, and and pressure grout up to the bearing pads. And then after the grout is cured, then release the beams or set the beams, release the false work from the beams. All right, for the LDCC filled MSE walls, obviously it's to backfill the new structure, it's to protect the new slabs during demolition, like I mentioned before, and it's also to mitigate settlement. We used Class 2 and Class 4 LDCC. Class 2 is a lighter weight material. That was the bulk of the MSE, or the LDCC, excuse me. But near the top, we wanted to have a stronger material to help further protect against the demolition activities that would be happening. One thing I wanted to point out, I'll turn on my laser pointer here real quick. One thing I wanted to point out is you can see, I think you can see these dashed lines here. That's the existing bridge that's in place, and the MSE wall straps would conflict with this exterior girder that's right here. And so so we couldn't complete the MSE wall before the weekend closure. We actually had to finish the construction of the MSE wall and place the reinforced fill along with the ag base and the pavement in that weekend closure. So here's a shot of the LDCC, them pouring the LDCC, which isn't really all that exciting. My junior engineers that I had out there with me were kind of like, is that it? I said, yeah, that's it. Here's a shot after they filled in the overacts, and they're just getting ready to start building the MSE walls. For some reason, I don't really have a good shot of actually during the MSE wall construction. One thing to note here is the pedestrian access. Like I mentioned before, during the filling and beyond the abutments, we moved the pedestrian access underneath the structure that's now been completed. Here's a shot of the project after the bridge is complete. The bridge construction is done, the walls are done. We're just waiting for the weekend closure to happen, getting prepared for that. You can see that the local improvements that we did as part of this project that connected to the City of Portland project to the route direction east are complete, and everything, the local road is opened back up, and we're just ready for the weekend closure. So the weekend closure, this is where the magic happened, you might say. The weekend closure started on Friday, June 28th, Friday evening on June 28th, and they brought, there's a lot of coordination ahead of time, a lot of planning, a lot of communication about what was going to happen and when it was going to happen and how it was going to happen. And an hour by hour schedule was developed by the contractor. And the length of the closure was 56 hours. That's what they were allowed to get it completed in. So they came out and started from the northbound side of the bridge and worked and kind of the south end, and then kind of worked their way back towards the north end. They to use the concrete as fill, they had to process all the concrete, which is one of the reasons why we suggested they use stone embankment instead of the concrete debris, is because of the time it would take to process the concrete and get the rebar out of there. So this is a shot on the right here showing the MSE wall fill, reinforced fill being constructed while they're doing the demolition or after they've demolished part of that structure. The photo on the left here is, I got it from the inspector that was out there at 1 o'clock. They were supposed to be done with all the concrete processing and the stone embankment placement and starting to place ag base, and they were not close to doing that work quite yet. So they were starting to fall behind schedule. This is at about midnight. I was out there with my boss, and we were checking things out. The superintendent and the owner of the construction company were, you can see in the picture on the left, were very concerned. One of the things that I realized at this moment, midnight on Saturday night, was that the contractor was using all the same crew for the fill placement. It was the same crew from Friday night all the way to Sunday morning. So when we were out there Saturday night, it was like, why is everybody moving so slow? And then I realized it's the same people that I saw Saturday morning when I went out there. So we're getting close. This is on Sunday. Sunday morning, they're starting to do the paving. At this point, or just before when they started to do the paving, they were 13 hours behind schedule on the 56-hour window. But miraculously, the contractor got it done and got it opened back up with 2 hours to spare. And this is a shot shortly after the weekend closure was complete. So going through kind of the proven value from a construction cost standpoint, we reduced the cost from 19 million down to 13.5 million. The schedule went from 24 months of more than 24 months of construction time to 18 months, and impacts to I-5 traffic. Instead of 5 stages over 2 years, it was 1 weekend with some limited nighttime lane closures. And being able to do the bridge demolition and construction without traffic in a work zone for I-5 is priceless. All right, some lessons learned. VE studies will ask you to kind of stretch your comfort level and kind of question the standards and why we do things the way we normally do. Just embrace that process, because there can really be some good value that comes out of that. If you're doing something unique, or a combination of things that are unique, it's good to have the decision makers at the table all at the same time. We went through, our process took 8 months to get from when we started the VE study until we knew exactly what we were doing, and there was some things that could have been avoided with that if we would have adhered to this. So the contractor constructability review was invaluable. It gave us the confidence to know that we could achieve what we were trying to achieve, and it really was reliant, with that weekend closure, really was reliant on their ability to do the work, and so that was great. And then on projects like this, especially when you're closing the freeway down, communicate some more, and then when you're sick of it, do it again, because the more that people are aware of what's going on and when it's gonna happen, it's really important. So I'll turn it over to Robert.
Thanks, Joel. Yeah, like I totally agree. It was priceless. Those VEs paid for themselves. So, how do we inform the public when closing a major interstate? The good news was most of the project work, the traveling public didn't notice much because it was being built under the new bridge, or the new bridge was being built under the existing bridge. Here's kind of a quick timeline of when the project kicked off in June. We had our VE study early. We went to the Mobility Advisory Committee, which is made up of the trucking industry and bike and ped, early in November. Then we had our contractor constructability review in January. We went back to the Mobility Advisory Committee, presented on this project. We opened up, we had an online open house in April. We published our construction approach decision out to the public in the summer of 22, and then our bid opening was September of 2022. We had a project website that was out there pushing information out to the public. Next slide. So preparing for the full closure, we coordinated with emergency response teams, our traffic management operations center, worked with the city of Portland signals and lighting, because there was a lot of on-ramps and off-ramps closed, state police patrol, and many others. Next slide. Our summary, the summary of some stats, we coordinated with over 9 other major agencies. Emails went out to thousands of subscribers, lots of visits on our website, and we even broke a record. This is the Dancing Girl, that 2.8 million views. So it was getting out. We're using social media, and of course local media outlets. Next slide. So when it was all done, all major risks were responded to prior to the closure. We were able to complete the full closure within 24 hours. And our construction office did not observe any severe traffic conditions. So like he said, Joel, it was priceless. Next slide.
Yeah, here's a time-lapse video of the construction. Just takes about a minute. I want to say this project was just an outstanding collaboration of a lot of different people. The work that we did with the communication we had and the collaboration we had with ODOT was amazing. The contractor review session that we had was invaluable. Like I said, it really provided us the confidence that we could do what we were trying to do and get that accomplished. We had just a lot of good communication and collaboration. In this video here, right there is where they started the paving. Again, that was 13 hours behind schedule, and they picked it up and were able to get it done. reprioritized some things, got the pavement completed. I wanted to mention the construction of the pavement was done with base course, with asphalt base course, all the way up to the top of the finished grade during the weekend closure, and then after the weekend closure, they did nighttime lane closures to grind and inlay a finished wearing surface, so they didn't have to go through the longer. It takes longer for that finished wearing surface to be constructed, and we couldn't fit that in the weekend closure. So that's something that we considered during the design and allowed the contractor to do. So with that, I think we'll turn it over to questions.
All right, thank you for such a great presentation, very informative. I also like to encourage ODOT to consider to submit this project for our project database and contact Mary Lou Rawls. And if you need more information, just let me know. I can put you. It's a very interesting project to be in our project database for others. At this point, we are going to turn it to Paul Lyles and Rick Liptic to moderate the question and answer period. Paul, you can take over.
Okay, Atarid, thank you. And we'll get Robert. Y'all get your cameras on.
Oh, sure.
Joel. Yeah, and this will be good. And we got a bunch of questions coming in, and y'all get some more questions in. So we'll try and go to it. First of all, these are some questions that came in before the pre-webinar questions, I call them. And the first one I have is, were SPMTs considered to move the completed bridge span into place? Did y'all consider that at all?
Yeah, SPMTs were considered. Ultimately we leave it up to the contractor how to figure out how to get the construction or the beams moved. We came up with, we like to show an idea in our plans, and then the contractor can propose what they want to do, and they decided that following along with what we had in our plans made the most sense.
Okay. Another question pre-webinar was, how were the ABC components incorporated into the usual bid items, or were they separated depending on scope?
So it's a good question. A lot of the items were didn't really require a whole lot of separation. There was the LDCC concrete was didn't really fit into the ODOT standard items all that well, and so there was a lot of adjustment to the specs to accommodate that process. There was a 200-page exception document that we had to put together and figure all this stuff out and and provide some examples of how other states have done the work. But they do have some specs specifically for accelerated bridge construction, and so they have they already have addressed some of these things for some previous projects, and so that was available to us. So the rest of it is, it's just like building concrete. So it didn't really require much adjustment.
Okay. We have an interesting question here on what is the fastest time to build an ABC bridge that has a span of 30 feet and is a railroad bridge? Do you have any opinion on that?
Oh my gosh, there's so many different questions that I could ask you back on that. But I would say I don't really have a good answer for that right now. I think it can happen pretty quickly if certain things align well for that process to happen.
That's a good response. If everything is lined up perfectly, and the railroad I know can do it pretty fast, but
right.
And whatever. But anyway, let's look at one here. What lateral and vertical acceleration values should be considered when designing the sliding system and evaluating the strength? Got any opinion on that?
It's a really good question. I don't have specific numbers at my fingertips right here right now, but I can respond to that. Can I respond to that after the?
Oh yeah,
after the session?
that'll be fine. All right. Yeah. But and there may be some values in the ABC specs even on that.
Mm-hmm. Yeah.
But anyway, okay, we got another question here. The method of engagement of the contracting community seems very effective. Is this common practice in Oregon? And does ODOT have rules of engagement for this type of interaction that can be shared?
Robert, you want to take that one?
You're muted.
There we go.
Okay.
Great. Yeah. Well, I mean, when this project started, this was kind of a new thing for ODOT with the value engineering. We lowered our threshold. The FHWA threshold was, I think, at 40 million. We lowered ours to 25 million for projects. So any project that's 25 million or over, we'll do a VE study. And then for the contractor constructability review, same thing. That was something fairly new that Zach Davis and Peter Kennedy coordinated with us, and we were able to create these one-on-one sessions with contractors that felt like they were in a safe environment. Like Joel mentioned, that information will be shared publicly. So they were able to help vet some of these practices to make sure that that'll work when we get out there. We didn't want to like try something new and then find out that it wouldn't work at all. And then we have a bunch of change orders we have to deal with. So it's been going on for, I don't want to say 3 to 4, maybe 6 years now. But this was kind of fairly new when we started this project back in, I don't know, when was it? When we started, 2020, about 4 years ago.
Okay, that's good. The next one is, were incentives and or disincentives included in the construction contract? And if yes, what were the values?
We didn't have any incentives, but the one disincentive was the liquidated damages that would apply to the contract if they didn't get done in time, especially for that full weekend closure.
Okay, you don't know the values, do you? Was it by the hour or by the day? What'd you do?
It's usually by the hour.
It was by the hour per lane.
Okay. Oh, okay. All right. Good. Then got a couple of new questions here that came in. The question here is, what is the vertical clearance under the new bridge?
Yeah, we were shooting for 16 feet. That was the kind of the goal. After we realized during the design that the adjacent bridge has just over 15 feet of clearance, and 26 way is it's not used by trucks, and so we kind of decided to allow for constructability to lower the roof, or the beams, you might say, down a little bit to accommodate some constructability and have a lower clearance there. So we ended up with, I think it was 14.4, I think is the clearance that we have there.
We also added, go ahead. We also added a sign at an intersection on the local road of that height limit. So that way, if trucks did decide they wanted to go down that local road, that they would see the limited height restriction and turn around at the intersection.
Okay. And there's another question later on. They asked about what was the pre-construction clearance. So you reduced it a little bit. Is that what you're telling me? Okay.
Yeah.
Like 6 inches, something like that.
No,
okay.
It was actually quite a bit more.
Oh, okay.
Yeah, it was a couple feet that we reduced it.
Okay. Then let me see here. The next one I'm going to ask, and then I'm going to turn it over to Rick after that. What was the delivery method for the project? Traditional design bid build or design build? Or GMC? Okay. And that was all along, y'all had that planned. Okay, so that's fine. Okay, it's approaching 2. We're not getting too many questions. Maybe we're getting some more here. I'm going to go ahead and turn it over to Rick because we've gotten into the Q&As. And Rick, are you there?
Yep.
Okay.
Thanks, Paul.
All right. Okay.
So somebody was interested in the design plans. I don't know if you have them on your website or if you can make them available. That might be helpful. Another thing, one of the question came up was, I noticed during your video there, during this, there was, rain. Go figure that it rains in Western Oregon, right? But how far in advance did that weekend get chosen that you did the closure? Was that set up in the contract, or was that something that you and your contractor negotiated out which weekend? And obviously you'd want the best weather, which wasn't rain, so you must have chose it, and then the weather changed. So anyway, maybe a little background on how you determined that.
You want me to take that one, Robert?
If you want, yeah. We gave them a couple of weekends, but at some point they had to choose one, and then we lucked out.
Yeah, exactly.
Yeah, some of the feedback that we got from the public was, you know, it was June 28th, so it was right before the weekend before the 4th of July. So, you know, there's never a great time to do something like this, Ben, but we felt like that would be better than the other option that we had out there.
Yeah. So the reduction in clearance, which you talked about the vertical, but I also, there was a question about maybe the horizontal reduction. You know, the piers obviously were out, looks like a little bit, and like the picture you have right here on the screen, you know, you had to get that sidewalk, that ped crossing in there and some other things, I guess. Was there much loss in lane, shoulder width, anything like that?
No, actually, this road was really wide. The road that was under there was unnecessarily wide, you might say. So they converted that to bike lanes and wider sidewalks. But the clearance that the city wanted originally, I believe it was 57 feet, or 57 feet was the existing horizontal clearances available, including the sidewalks. And they would have loved to have maintained that, of course, but with our choice of structure here, we had to reduce it down somewhat. So we gave them as much as we possibly could with and still be able to provide that structure inside of that center span.
Yeah, and
Okay.
I wanted to point out too that they had local parking under that bridge, which ended up bringing in, you know, camps as well, homeless camps.
Sure.
So by removing the parking, we have this fairly lit. There's a lot of lighting under there as well.
Okay.
And then on the sides, if the folks care, we went to maintenance on like how are we going to maintain so we don't get any graffiti on the walls. So long term, we're going to use vines, so vegetation vines to cover up the wall, which works great. But in the immediate, we're going to try to monitor it and try to keep it clean until the vines start growing.
Okay, well, it looks like we're getting to the end here, so I guess we'll have to wrap it up, and we'll turn it over to Adirad. It was a good project, and you know, it had some good questions, and I want to thank you very much for showing us this project. So I guess I'll turn it over to you, Adirad.
All right, thank you. Very, very interesting the project, and like I said, I hope that the ODOT will consider to provide the information about this project, so Mary Lou Rawls, who's in charge of the project database, can include it in our project database, which is a great resource for all the bridge engineer. On that note, we will conclude our December 2024 webinar.